afternoon. I'm Shane. I'm going to be Samiha from the Institute. I'm privileged to introduce Aliya Samiha, the effect of chronic exercise on myeloid-derived suppressor cell population in a rat mammary model.
Yeah, so I'm Samiha. I'm Aliya, and for the past 6 years we've been working with Dr. Whitehouse with our lecturer at research to study the effects of chronic exercise on myeloid-derived suppressor cell counts in a rat mammary adenocarcinoma model. And so, cancer is a very prevalent issue worldwide, and so much so that in 2017 it was estimated that over 1.5 million people would be diagnosed with this disease, and out of those, 1 in 5 would die. And because of this, scientists have been looking into different treatments for cancer, and in the past few years they've looked at vector cancer. This idea of exercise oncology is actually being implemented right now at the University of Northern Colorado's Cancer Rehabilitation Institute, which is an institution that we're affiliated with. They're taking people in all stages of cancer, pre-treatment, people who are currently getting treatment, and people who have graduated treatment. And they do a variety of different exercises with different intensity interventions to study the physiological effects that exercise has on cancer. They have found that cancer and exercise during cancer can relieve cancer fatigue, the side effects of chemotherapy, and can improve lung strength and endurance. And on top of that, exercise also reduces the risk of cancer recurrence in the patient and tumor metastasis. And tumor metastasis are where the tumor spreads throughout the body, as shown in the diagram here, where it moves from the primary cancer tumor to the lungs into the brain. And 90% of cancer patients die of tumor metastases rather than a relational tumor. Well, it's nice that the Cancer Rehab Institute and other places like that have seen all these positive physiological benefits. We actually have no idea why biologically speaking cancer and exercise have anything to do with each other. There have been no studies done on the effects that exercise has on cancer cells. There has, however, been research done into the effects of cancer on the immune system. Yeah. And so exercise, it just really makes you feel better, such as reducing the effects of chronic diseases and diabetes and obesity. And because of this, immune therapies has become very prevalent because chemotherapy and surgery have caused a lot of negative side effects, and so because we want to find ones that don't really need to exercise, and cancer treatments haven't evolved since the 70s when the first chemotherapy chemical was discovered. So we specifically are looking at the effects of exercise on myeloid-derived suppressor cells. And so what these are myeloid cells that are supposed to become either macrophages or neutrophils or dendritic cells, but in the process of them getting to their growth cycle is disrupted, and they have become immunosuppressive cells. And so, as you can see over here, myeloid cells develop in the bone marrow, and then they are generally supposed to become different sort of macrophages, or they become neutrophils. But in case they are hijacked, they become these suppressor cells that prevent the immune system from doing what it needs to do to prevent And so, as we kind of touched on, MDSCs are extremely immune suppressive. And they tend to accumulate around systems with a lot of inflammation. Myeloid-derived suppressor cells are actually originally found in chronic infections such as tuberculosis. And because of this, they're linked to treatment resistance, which essentially just allow the tumor to grow more than it would if your body was able to react to the immune system. These myeloid-derived suppressor cells shouldn't be existing in any healthy human or any healthy animal, that they are what suppress your immune system and keep you from being able to combat disease such as cancer. And so your immune system is very show that your immune system is always killing off cancer cells, and when MDSC goes present, it allows the tumor to escape the immune system. So, and shown here in the diagram, these T cells are what attack the tumor cells, so like natural killer cells. And the MDSC suppress these T cells and natural killer cells, resulting in the tumor to grow and spread. And because of the danger of MDSCs and how little known there is about them, we wanted to look into if exercise had a negative or positive effect on MDSCs, and we hypothesized that exercise will reduce the count. So for our study, we separated our lab rats into two groups, exercise and sedentary. In the study, we're actually using Fisher 3.4 rats, and then those two groups are being separated into tumor-bearing and non-tumor-bearing rats. We will then allow them to run for 4 weeks prior to inoculation with a line of testing known as NAPI3. We chose NAPI3 because the rats are syngeneic to the line of cancer, which essentially just means that their immune system is going to reject the cancer and will allow the tumor to grow and allow the MDSC to develop. We also chose NAPI3 because it's a more gradual tumor development process, which makes it more similar to the way that humans develop cancer. So after those 4 weeks, we will inject them with NAPI3 and allow them to continue running for 21 days or until their tumors grow to 3 centimeters in either direction. At this point, the rats will be euthanized and their bone marrow and blood will be harvested and put into single-cell suspension for analysis through flow cytometry. And so to analyze through flow cytometry, the cells are marked with HIS48 and CD11BC markers. And so these markers, cells have surface markers, and the antibodies bind to the surface markers, which then bind chlorophores, and the antibodies enter the surface. And when this laser is on the and so in this graph, and then the first thing here is the usable positive and then the second one is a double positive for CD11BC38, which is for the MDSC. And then we have the double negative for CD11BC38, which are where these cells and T cells. And then the fourth project is positive for And so here we have our bone marrow. And the first one is a sedentary non-tumor grant. And here we have the isotype. The nature of the negative control, so it's not being the CD48 or CD11BC. And there are these MDSC which is what is accepted for negative control. And then here, for the stained samples, there aren't MDSCs either, and that's due to it being a healthy rat and there not being a tumor, which is also accepted. And here we have the sedentary tumor there, and as you can see, there is a significant amount of MDSCs, and additionally, in the exercise tumor brains, there are MDSC populations. In the blood of the rat, we also found similar results. In the sedentary non-tumor brains, the genotype, there are no MDSCs found, which is good because there shouldn't be any in this since there are no antibody stains. And even in the actual blood samples, there are no MDSCs because the rat was not injected into the skin cancer, so it had a normal immune system. In the sedentary tumor area, however, you can see that there is a large population of MDSCs in that second pocket. 81% of the cells, in fact, that we ran through the flow cytometer happen to be MDSCs. This is because of not only the fact that they were injected with cancer, but because they were sedentary, as compared to the exercise tumor, where even though there is a distinct population of MDSCs, it is significantly smaller than that of the sedentary effect. And so here we have the averages for the bone marrow tissue and the decrease. And so as you can see, the sedentary non-tumor brain versus the sedentary tumor, we have significant population, which is the sedentary tumor having. However, the sedentary tumor brain versus exercise tumor brain, both in MDSC are not produced. In the blood, however, there was just a showing that there is a connection between exercise and the in the blood. In the sedentary non-tumor brain, there are advantages, which again is not being but in the sedentary tumor brain, there is a high MDS that is significantly higher than the count in the exercise. There's also the fact that the exercise is longer than the shadow and the very life. As you can see, the average weight in the exercise is only 2.17 one thing you may have noticed, you don't have any data on here or the exercise non-tumor during that. And that is because in the studies we had a relatively small sample size. And so 2 out of 3 non-tumor cancer have been discovered. However, the one that stayed had a significantly high amount of MDSC, and this is, well, we want to see if it is either due to exercise or is an anomaly, and so we would need a larger sample size of non-tumor bearing exercise individuals. So we like to thank our lecturers at the University of Pennsylvania for helping us with our research. And we would like to thank Dr. Reed Hayward and Dr. Nick Summers for providing us too. We'd also like to thank our advisor, Shane Murphy, for helping us with our presentation. And we'd like to thank our program coordinator, Ms. Lauren Hall. We'd like to thank our inflatable dinosaur lab technician, Ariana Cornelius, and take pictures. And we'd like to thank our sponsors. I'd like to thank the Morris family and the New Pacific Foundation. And thank Accelerate for sponsoring our dinner at the Giant Law Research. They got sick. Next question. Okay, you would go to the data from like the lab. No, keep going. I'm going to cover you. Yeah, okay. So in the exercise tumor bearing, there is a population of PD-1 PD plus, and or like with a and what is that? 648, 40. Okay. So there is a population with relatively high 48 and probably moderate amount of PD-1C. So why, I guess, is there a population so isolated from, or why is the MDSC population so isolated from the actual population? Does that sound really good population? Yeah, and so I guess in the sedentary tumor bearing, the population of MDSC seems to be more concentrated, closer with lower concentrations of CD11B and 48. And so I guess in the sedentary tumor bearing, the population of MDSC seems to be more concentrated, closer with lower concentrations of CD11B and 48. And so I guess in the sedentary tumor bearing, the population of MDSC seems to be more concentrated, closer with lower concentrations of CD11B and 48. So the question is why the exercise tumor bearing MDSC population so isolated from the double negative population? So that's due to MDSC being positive to both CD48 and CD1 ABC, while these cells are not, and so it's because it has. And actually, all these cells down here are just other immune cells that we don't choose on the type. The MDSCs are only the ones that show the positive for those in 48 and 11. Right? So, are you talking about autoimmune disease or disorder disease? Are there higher levels of MDSCs? Yes. So, MDSCs are just associated with cancer. They're associated with a lot of those infections. Like I said earlier, actually, they were first discovered in chronic diseases, especially tuberculosis, and they tend to accumulate wherever there's inflammation. So it's not just for cancer, not just having to be removed with cancer. Yeah. So, when there's a high number of MDSC cells, is it bad? Like, is it bad because it's removed or is it bad because it's So the question was, is it bad if there's a higher MDSC count among the diseases? I think it's a mixture of both because the MDSCs can make it worse. They exist in the disease. So there are certain situations in which you want MDSCs in your body, but that's just if they're not in pregnancy. You don't want your immune system killing off the fetus inside of you. So in that case, MDSCs are very beneficial. But in cases like cancer, where they allow the tumor to grow, we don't want to have that. Okay, so why are MDSC cells like okay, so the question was why are MDSC, why do they develop and why are they spread in the body? And to me, the conclusion that is because one of the main reasons because of pregnancy is to keep your immune system from attacking the fetus.
You said that it was all reduction in yeah. Can you is that expected?
So the question was, is expected that the results in bone marrow are not significant. The reason for that is essentially just because we had a really small sample size. In the cohorts, we just had 3 rats for each type, and especially in the exercise non-tumor area, 2 of the rats actually became reunited. So to find significantly, like to distribute significant numbers, we would need to repeat the study with more rats and see what compare numbers.
The exercise regimen for the rats. Can you tell us a little bit about it?
Okay. So the question is to explain a little more of the exercise regimen. And so the rats were they were exercised for 4 weeks before they were injected. And after that they were off the wheel for a little bit. And then they were put back on the wheel, and after every 21 days or once it was 2 centimeters, like the tumor was 2 centimeters anyway, then they would leave it. And the exercise is completely voluntary. They have no wheels in their patients, and they have the option to, that's why they also give them 4 weeks prior to inoculation, so that they can use to run out of the wheel. But it's completely just voluntary or exercise. And then the exercise is measured by the cycle unit, so every time they go there and once